Thank you. I will try to be very crisp because I am between your lunch, and I think it's a time wherein we can test our sustainability. So let us sustain for 10 minutes. And what I will talk basically, I'm not going to talk anything about what Forbes Marshall is, that we can meet separately. But whatever is being talked and whatever we understand, I will present that. I'll present some open questions also, ki what can be the technology, what can be the new trends, and then we can have over the day, we can have a lot of discussions. So the topic, we have heard so many things, whether it's a energy intensity reduction, whether it's a sustainability, whether it's a technology. So what we feel from Forbes Marshall, what are the typical priorities in any chemical plant? And if I have to bucket it into the two major things, I would say first, energy reduction. And the moment we reduce the energy, the emission would also reduce. So it goes hand in hand. The second is how I can maximize my water how I can maximize my percentage of water which is being reused. Okay. And when I further deep down that energy reduction, then there are various opportunities. How I can reduce a process steam consumption, how I can optimize the waste heat recovery, what are the renewables which I should look for, and the technology. Technology part I will talk a bit because we have to be at present also, and there are a lot of fancy things also, so some of the basics I will try to cover from my end over there. Water, right now today 10 minutes, I am not covering that. We can meet at a stall to discuss more on the water. But as far as the chemical plant is concerned, we can do a lot of things, particularly looking at the ME and the condensate recovery over there. So coming to where we are today, and this again I am not naming the customer name, learning from the earlier presentation, but when we talk of sustainability, when we talk of what we will do better, where we are, it should be clear. So what is our understanding? This is one of our customer. 90% of the energy what they are using is from the coal as of today. Okay, and the percentage of water recycled is at around 40%. Okay, I am just trying to give you some correlation. Now you see that the 90% of the energy was from coal, and the total coal which is consumed for a steam generation was around 1440 TPD, out of which the coal which is used for the steam generation is almost 70-75%. So what I am trying to say, in today's context, most of the chemical plants are using coal. We want to move towards biomass, hydrogen. I'll talk all about that, electricity. But as of now, we are using 90% of the coal. And out of that, 70-75% of the coal is used for a steam generation. That means if I have to reduce my CO2 emission, I have to reduce my steam intensity. So that is the first thing I think if you can take back out of this presentation, I would be very happy. So it's the only slide 2, and these are the real customer details, and we have verified it across the industry also. So what we have delivered to this group from 2017 to 2022 in a span of 5 years across their 5 plants. Most of the plants are in and around Bharuch, one in Vapi. You can see a huge steam savings of around 10%, the equivalent CO2 reduction of around 15%, only fuel bill savings of 40 crore, and additional water savings of around 800 to 900 KLPD. So 40% what was the water reusable with our, I would say, the continuous engagement and focusing on the basic thing. Now the today recycle content is close to the 56%. So those 10 crore savings on account of the water and effluent cost is over and above of this. So 50 crore savings we have delivered to a prominent chemical group by our continuous engagement in last 5 years. What did we do and what we can associate with all of you, because we are talking about automation, we are talking about the sustainability, we are talking about the carbon reduction. So our say is that all these will be applicable based on what your plant energy intensity is and how we map the energy intensity with various technologies. And I'll come on that slide and how we can help you irrespective of whichever small or big plant you are or whatever is your project. Just see on the left-hand side wherein we are saying if it's an existing plant, we can get engaged with a thermal assessment. If it's a new project, we can engage with a detail engineering. And in both of the things, what is a value addition? And we spoke about how value addition is being done in the process. Same on the utilities. Our value addition is how we can use a domain knowledge of steam and other utilities and then use all the AI platforms so that there is an ongoing engagement, real-time engagement 24/7. The same thing what we spoke for a process in an earlier presentation, our value addition is to not only take a data, but to give you inputs that what is to be done on that data, what is the corrective action. If boiler efficiency is low, why the boiler efficiency is low and what I should change, what parameter I need to change so that my boiler efficiency comes to a original number. If condensate recovery is low, why condensate recovery is low and what corrective action I will do so that it comes to an original value. So this is the method we are saying for engaging with you, which is totally from a services. Products I am not going to talk in today's presentation, and we can discuss more when we meet at our stall. Now I'll take some time on this slide. It might be debatable. You may feel it that I am against technology. I am not against technology. This is just to have a basic things clear in our mind. The option 1, you can see there are various scenarios. And why we have plotted these scenarios? We have just plotted these scenarios for our own understanding also what product, what technology we need to work and how the industry is moving on, and your inputs would be more than welcome on that. The first scenario is we are generating a steam with a coal, and you can just have a look at a fuel cost. These are the average cost. Don't worry for the numbers. There might be some variation. So 7 to 9 rupees, average we have taken 8. Same thing if we continue with a coal as a steam generation, but we put a carbon capture technology, which today there is I am saying we are not using a carbon capture technology. As of today, what happens? I'll come on the conclusion. Just first focus on the first 2-3 rows. The scenario 3, we were talking about the decarbonization. So what happens if I shift to the steam generation on the biomass? The biomass cost is around 5.5 to 8.5. For calculation purpose, I have taken 7. The next thing, buzzword, hydrogen. What happens if I generate my steam on hydrogen? Our experience says right now it is better to sell the hydrogen if you have, instead of thinking of getting into any steam generation. But anyway, we will talk on that. What happens if I have a green electricity available with me? There I have taken a cost of 4 to 6 rupees after subsidy. And then what if I don't have a green electricity and I directly use electricity as a utility? So you can see the steam cost in the first option, you can see is around 1.6 rupees. The steam cost with a carbon capture is also 1.6 rupees, the fourth row from the bottom. Now what happens in the first versus second, the first version, I am able to reduce the energy intensity by 21%. So I can indirectly reduce the emission also by 21%. When I go with a carbon capture, still I can reduce the energy intensity by 21%, but emission reduction I can reduce by 100% because there I am capturing all the carbon which is formed in the stack. What is an additional investment over there is whatever capex is required for the carbon capture. I move to biomass, the same thing remains. Emission, I can still deliver you the 20% savings. That 120% emission reduction means now I am plus 20%. So instead of 100% reduction, I can sell the credit into the market because I am on a biomass. So that's why it is 120%. What is the investment over there is roughly 36 months ROI. So we were talking about ROI because the capex investment would be needed. Hydrogen, we have tried to use hydrogen at couple of places, not directly into the boilers, but for mixing into the furnace and all. As per our knowledge, the cost is right now 400 rupees. With that, the economy doesn't fit into. Right now, the cost of steam would be at around 9 rupees. Even if we talk of green hydrogen, which people are claiming that we will get in a $1, which is around 85 to 90 rupees, still the cost of steam would be higher than 1.6. So that is where we are today. I am not saying that we are against technology. We are ready with the burners. If we get a cheaper hydrogen, we will provide you the boilers with a hydrogen. So that's where I am clubbing the technology part with what is available for our industry. With a green electricity, we are ready with the electrical boilers. Again, if we have an subsidized electricity, then only electrical boiler will make a sense. Just few thumb rules. For 1 ton of steam generation, we need 700 kilowatt of electricity. Okay. I am sure that in Bharuch, average boiler capacity is 10 ton or more. So I am saying the steam consumption would be 10 ton. If you have to go for an electrical boiler, you will have to first maintain a one substation of 7 megawatt. I don't think it is feasible. So such things should be clear in our mind. That's the purpose we are presenting to you. So when we talk of electricity, we should try to again think what are our requirements and how I can club electricity requirement with few of the application wherein I reduce the steam intensity. I'll give you a couple of examples. Say take a heat pump. Okay, so we can think of MVR technologies, which is being extensively used, wherein the first phase is being used with the help of electricity, and second phase we use a rotary, I would say the vacuum blower for transfer of vapors from the phases, so that wherein I am reducing the steam intensity and substituting it with a electricity. Second example, there can be heat pumps. Again, all these technologies we are coming up with. We are developing a heat pumps with very high COP of around 4 to 5, which can give you a localized steam. So in heat pumps, we are planning around 500 kgs of steam with 300 kilowatt of power consumption, which can be localized use, or 200 kilowatt of chilling load also along with that. So with electricity, our say today is, let us go for a hybrid technology. Don't think of, I will replace all the boilers with electric boilers. It's not going to happen. Again, we'll have to map the sink and the total plant heat and mass balance, and then we'll have to validate where we can replace those consumptions with the electricity. So here what we are trying to say, even in scenario 1, wherever you are, there are opportunities to reduce the energy intensity by 21%, which will reduce the emission also by 21%. If we have an capex, we should go for a carbon capture. If we have a more capex, we should go for biomass. We can become a carbon neutral. We can trade the carbon also. If we have an excess electricity, come to us. We can audit your plant and we will say what is the best suited application for you, whether it's an electric boiler, whether it's a heat pump, anything. And then if you have an only sole electricity as a direct utility, that scenario we don't see which can be used for a steam generation. So this is basically combining current situation, upcoming technologies, and how the situation would be. Coming to the 21%, in any typical chemical plant, we know most of the steams is being used in the column and then in the ZLD, and then balance of plant around 27%. So even if in your plant, only if you work on the distillation column, SRUs and ME, I think we can contribute almost 10 to 12% of the original 21% what I said. So here again, many examples, number of customers in this area, you can see there is a productivity benefit of batch time reduction, steam consumption. This is only for that SRU. So this is not on an overall plant. But even on one equipment, if we work, the savings possible is around 4 to 6%. You can visit our stall and we can give you all the details. So what we want to do with you, we want that we should have an engagement wherein we are monitoring all the important parameters at a plant level. So your first goal is to reduce the greenhouse gases emission, which we are saying carbon neutrality, or even government is saying 2070, but most of the corporates have a plans which is around 2040, 2045. We are not waiting till 2070. So if that is my goal, how I can achieve it? By CO2 generation and water. Here I am talking of mostly of scope 1 and scope 2. I am not talking of scope 3 because which is not under our purview. Within CO2 generation, we talk about if we can monitor what is my steam generation, and if that steam generation is going higher, because of what reasons it is going higher, and if I can control it. The same way, what is my condensate recovery factor, and what is my grid power ratio, usage of grid power ratio. So within steam, again we can monitor what is the steam to fuel ratio, what is the fuel consumption only for process, and what is the fuel consumption for the ZLD, because we spoke that ultimately it should not happen that while monitoring, or while I would say monitoring the rules and regulation, we are consuming more steam. Same way for grid, what is the power consumption in a day, and how much it is out of that total power consumption is from renewable and how much is from the grid. And same on the water, what is my specific water consumption and how much is the recycle percentage. So what we are saying, we are helping, and there are around now 600 plus plants which are connected to our cloud. We are monitoring all this data. Just couple of examples I will give which are out of chemical industry, but to know you, say for a textile plant and a leading brands today, any brand, they need to print on a t-shirt how much CO2 they are emitting for manufacturing of those t-shirt. And I am talking this in a belt like Coimbatore, I am not, and in a belt like Surat. So that is where we are engaged with them in providing such dashboards and telling them that how much is the CO2, I would say, emission per product, what they are manufacturing. The second thing is, you take another example of, say, brewery, wherein we have been working since 2003, and since 2003 to 2023, the brewery production has increased by 20 times, whereas the steam what they are consuming for their process is still the same, or it is a reduced one because of the continuous engagement. So we invite all of you to get your plant studied, scoping study done, and then we can evaluate how the technology and the existing part can fit together and we can work together. Thank you. We have an one minute video if you allow, Mr. Prashant. It's a 1 minute video only.